Mindsetters, welcome to today's Grade 10 Maths Show. Today we have a special revision lesson on finance and statistics. We have selected highlights from lessons shown earlier in the term to help you revise this term's work. So please post your comments and your questions on our Facebook page or on Twitter at LearnExtra so we can help you with your revision. You can also download the show notes for today's lesson from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
We are told that Dave invests 4,600 Rand for 4 years at 10% per annum, simple interest. Okay, very important point there. This is simple interest. So as I said, we don't really need a timeline, but let's use one. Again, the wrong line. There we go. All right, so he invested for 4 years. So starting off now, he's putting that money into a bank or wherever he's putting it. He's doing that investment now. So that's times 0. How much is he putting away? He's putting away 4,600 Rand. Okay. And this is invested for 4 years at 10%. So this is going to go all the way. So we've got year 1, year 2, all the way to year 4. Okay. And during that period, your interest rate or his interest rate is 10% per annum, simple interest. Now, guys, remember, if they're talking about simple interest, we need to just note here the formula we're going to be using is our simple interest formula, 1 plus I times N. Okay, so that's what we're using for the first 4 years, and you've been told that the interest rate in those 4 years is 10%. So we'll write the decimal form of that. So we do 10 divided by 100, and you get 0.1. Okay, so the interest rate at work for the first 4 years is 10% simple interest. Then he invests the accumulated amount. So whatever he has at this point in time, he then takes that and he invests it for another 2 years at 12% per annum, but now it's compound interest. So another 2 years. So we're going to carry on our timeline. We've got year 5 and then year 6. Okay, so whatever he's got at that point, he takes that and he invests it for 2 years at 12% per annum compound interest. Compound interest, that means for the final 2 years, what are we going to be using? The compound interest formula. Okay, 1 plus I to the power of N. Your interest rate at work in those last 2 years, in decimal form, we're going to take 12 divided by 100, and you get 0.12. So your interest rate here is 0.12. Once you've summarized everything into this timeline, guys, it's actually very easy to then decipher or decide what it is that you need to do from your timeline, okay? You can see that he put that amount in, 4,600 Rand. That is then worked on by simple interest for a 4-year period. At that point in time, time 4, whatever accumulated amount is in that account is then invested for a further 2 years, and that is then at a compound interest of 12%. So let's write all of this down into a solution. All right, so I'm going to say at time 6, so at the end of the period, the final amount is going to be equal to the initial amount, which is 4,600 Rand, and that is at a compound interest rate of 10% for a period of 4 years. Now at this point you can decide, you can either then use your calculator and work out what this value is. You can do that. So you can work out this value If you're going to use your calculator at this point, guys, and you're going to work out what is the value of this 4,600 Rand, keep every single decimal point. Don't round off at all, because the question is not yet over and you don't want to introduce rounding off errors. So at this point, if you're using your calculator, use your calculator memory and keep that entire figure in the memory, which you're going to use for the rest of the question. I'm not going to use the calculator at that point. I want to show you guys the much more efficient way to do this. So this will give us the value, or the value of the investments at point, or at the 4th year, okay? But we then know that whatever's in there, so this entire amount, whatever's in there, is going to be reinvested at a compound interest rate of 12%. So if I want to move from time 4 to time 6, I simply need to take my accumulated amount and use my compound interest formula. So it's 1 plus 0.12 to the power of 2. I use my compound interest formula to take this amount at time 4 and move it all the way to the end of the time period. When I've written it out like this, there's no need for me to round off or anything, because I'm going to put this entire thing into the calculator and see what we get. Okay, so we've got 4,000. All right, Smart Ink, there we go. Smart Ink, turn on, turn off. What do we do here? Hopefully that's gone. There we go. Okay, so we're going to write in exactly what we see. We've got 4,600 Rand, simple interest, 1 plus 0.1 times 4, close brackets, and then close brackets again. That whole thing is going to be moved forward for 2 years at 12%, so it's 1.12. All I've done there is I've added the 1 and the 0.2, and that's going to be to the power of 2. Okay, so our entire calculation in one step, and we get an answer of 8,078.34. So 8,078.34 if we round it to the nearest cent. All right. So he's going to, if he puts 4,600 Rand, unlike if he just put it under his bed and slept on it, it's going to stay 4,600 Rand in 6 years' time. If he invested it at simple interest and then it was increased to compound interest, he'll end up with close to double the amount. Not quite, but close to double the amount when at the end of the 6-year period. Here we are asked to find a different variable. We're asked to calculate the number of years needed to invest 1,000 Rand. Okay, so again, we'll write down each of our variables, and let's have a look at which one they're asking us to find. Calculate the number of years. Obviously, they're looking for N. Needed to invest 1,000 Rand. Invest, you're starting with your original amount is 1,000 Rand. In order for it to accumulate, your final value is going to be 2,500 Rand. And at a simple interest rate of 8.2% per annum. Remember, when you're using your formula, you always put the decimal form of that in, so it's going to be 0.082, which is simply 8.2 divided by 100. Okay, so therefore, once we've written all of the information down that we have and what we're looking for, it's just a straightforward application of the formula. Once again, we're working with simple interest, so we're using A is equal to P times 1 plus I times N. All right? We know that the final amount is 2,500. The initial amount is 1,000. And the interest rate is 0.082. So we were looking for N. Okay, so once again, we strip away from all the N, we get rid of all the other values, and let's get N by itself. So the first thing I'm going to do is divide both sides by 1,000. So it's 2,500. Let's just erase that. 2,500 divided by 1,000. And we want to get rid of that 1 there, so we subtract it to the left-hand side, is equal to 0.082 times n. If I want to get rid of 0.082, I need to divide this whole thing by 0.082. So just changing the subject of the formula so we can get n by itself. And once again, it's just a matter of putting all of this into your calculator. Remember, they asked us n in years, right? Okay. So we've got 2,500 over 1,000 minus 1. Close that bracket, and then the whole thing is divided by 0.082. As you can see, we're doing everything on the calculator. We're not rounding off at any stage, and therefore we get an answer of 18.29 years. All right. Now, guys, this is not sufficient. You can't stop here. 18.29 years can be more explicitly explained because it's 18,29 years. So I know it's going to be 18 years and a couple of months. Hey, so I want to find out how many months. And remember, there's 12 months in a year. So if I subtract 18, I'm going to be left with 0.2926, which is just the decimal part of your answer in year forms. So that's a fraction of a year. If we times that by 12, we'll get 3.5. You want to round up because remember, if you keep it at 3.5, it's not going to accumulate to the amount of 2,500 Rand. You need to round up here. So 3.5 will be 18 years and 4 months. Okay, so you've got to round up. You can't leave it as 18.29. You need to state your 0.29 in a matter of months. And remember, if it's something like 3,5, you need to round up. You need to go 1 up, as you always will do if you're rounding to 1 decimal place. The reason for that is if you put n here as 18 years and 3 months, you will not get your principal amount of 1,000 Rand, taking you to 2,500. It will fall short. Okay, so those little things are important. If they ask you for an answer in years, you will need to give years and months if you've got a fractional or decimal point in your remainder. All right. Okay, let's have a look at question 3. And this time we're looking at some compound interest. Here we're told that Morgan invests, and we're going to do the same thing as we did before, guys. We're going to list the values for A, I, P, and N, and let's have a look at what they're looking for. So Morgan invests 5,000 Rand, invests 5,000 Rand, so therefore P is equal to 5,000, into an account which pays out a lump sum at the end of 5 years. So N is equal to 5. If he gets 7,500 Rand at the end of that period, so A, your final amount is 7,500, what compound interest rate did the bank offer him? So they're looking for R. Obviously, we'll work out I and then times by 100 to get R. Okay, so we're looking for I here. We're dealing with compound interest. Therefore, we need to use the compound interest. That implies that your interest is worked out on your original amount and any accumulated interest. The formula is A is equal to P times 1 plus I to the power of N. All right. Once again, we're going to strip away. We're going to fill in the values that we know, and we're going to strip it away to look for I. Okay. So A, the final amount we know is 7,500. Your initial amount was 5,000. And we are looking for the value of I, so obviously we don't know that, and N is equal to 5. All right. Remember, it is important, if N is in years, your interest rate needs to be annual. All right, so let's divide through by the 5,000. So I get 7,500 divided by 5,000 is equal to 1 plus I to the power of 5. You want to get rid of the power 5. We can take the 5th root on both sides, or we raise both sides to the power 1 over 5. It's the exact same thing, because remember, the 5th root is the same as raising to the power 1 over 5. So we take the 5th root of 7,500 divided by 5,000, and then I'm just left with 1 plus I. Okay, and then to get to the I need to subtract 1. So fifth root of that minus 1 will give me the interest rate in decimal form. Okay, at this point we put everything into our calculator. So we're looking for the fifth root, or as I said, if you don't like working with the fifth root, you can use to the power of 1 over 5. I'm going to use the fifth root, but if you prefer, you guys can use to the power 1 over 5. Okay, so it's the fifth root of 7,500 over 5,000. Okay, from that we subtract 1. And you get an answer of 0,084, so therefore I is equal to 0,08 if we were rounding off to 2 decimal places, or 0,084 if it's 3 decimal places. Therefore your interest rate will be times that by 100, and you get 8,4%. Okay, so therefore the interest rate using compound interest that will take 5,000 Rand and make it 7,500 Rand over 5 years is 8,4%. Alright, okay guys, so it's important that you understand the application of your formulae to find any variable that you're looking for. You need to be able to find I, N, A, or P. Alright, before I go into question 4, I just want to check with Looney and see if any questions have arisen for us so far.
No, not yet. We don't have any question.
No questions, so we can continue to question 4, or are we taking a break?
We can continue.
Alright. Okay guys, so with the authority invested in Looney, we will continue with question 4, so still dealing with compound interest. Here we are told that Nicola wants to invest some money, obviously some money, we don't know how much, at a compound interest rate of 11% per annum. How much money to the nearest Rand should be invested if she wants to reach a sum of 100,000 Rand in 5 years' time? So what do we have? We know that A, the final amount that she wants to get at the end of the period is 100,000. Okay. P, how much should she invest? That's what we're looking for. How much can she put in so that she gets 100,000 at the end of the period? The period being 5 years. And the interest rate is 11%. All right. So we're looking for P. We've got A, N, and I. So we're going to say 100,000 is equal to P times 1 plus I. I is 0.11, so it's going to be 1,11 to the power of N, power of 5. Right, we're looking for P, so we divide both sides by 1.11 to the power of 5, so we get P is equal to 100,000 divided by 1.11 to the power of 5. Alright, so you're simply going to put that into your calculator. Let's see what we get. So we've got 100,000 divided by 1.11 to the power of 5. And that's going to give us 59,345 Rand. 59,300. And let's have a look at the last one, because remember they did say to the nearest Rand, so that means let's round it off to 1 decimal place. And to 1 decimal place, it's going to simply be 59,345 Rand to the nearest Rand.
Okay guys, I hope you're enjoying this revision session. If you are struggling and need help, please post on the page or send your questions to the Learn Extra Help Desk. The links are on our Facebook page. But now it's time to take a very quick break. Don't go away, we'll be right back. Welcome back from the break, guys. Doing revision is really important, so I hope you are enjoying this lesson. I'd love to chat to you on our Facebook page or on Twitter, so please let us know how you are doing. Enough of the chat, now it's time to get back to some more revision.
Looking at a little bit of inflation in this one. Here we know that, we're told that a union leader says that salaries have to double every 7 years to keep up with the rate of inflation. So what average yearly rate of inflation does he imply? So what is the interest? So if you were looking for, and I mean this is quite also a real life situation, I think, because you often hear union leaders calling for 10% increase, 20% increase, sometimes ridiculous amounts. How do they get that? Well, let's have a look. Okay, so here we know that salaries have to double every 7 years. They don't give you a specific value. All they tell you is that it's got to double. So if your initial salary P is X, then the final salary or the accumulated amount we want at the end of that 7 years has got to be 2 times X. Okay, so by using a variable, we're saying it doesn't matter what amount it is, it's going to be 2 times that amount at the end. Okay, so your X is just your placeholder. And every 7 years, we know that N is equal to 7. What average rate of inflation does he imply? Now, guys, think about this. How are you going to do this? Okay, hopefully you've all been paying attention in class and you've been paying attention now during the show. We're talking about inflation. We know what N is, we know what A is, we know what P is, and we need to work out the value for I. But now, do you use simple interest or do you use compound interest? What do we use to work out inflation? And for those of you who were listening right at the beginning when we did the summary, you would remember that I stated right at the outset that whenever you're looking at inflation, you use the compound interest formula. Okay, so the formula we're going to be using is A is equal to P times 1 plus I to the power of N. And the variable we're looking for is I. All right, so the final amount is going to be 2 times whatever the original amount was. And when we set it out in this way, you can see it actually seems to be a pretty straightforward calculation. All right? We're trying to get to the I, so if I divide both sides by X, obviously X is a salary, so it's never going to be naught. It's not possible because no one will work for nothing. Okay, so therefore X can't be naught. I divide both sides by X. And I'll get 2 is equal to 1 plus I to the power of 7. In order to get rid of that 7 there, the power, we can take the 7th root on both sides. All right, and here if I raise that to the power of 1 over 7, the 7's cancel, and I just get 1 plus I. So therefore I will be equal to the 7th root of 2 minus 1. All right, and then we simply need to use our calculator to work that out. So the 7th root, so on your calculator, it's shift and that button, and it's the 7th root of 2 minus 1. So in decimal form, your interest rate is 0,104. Alright, so therefore, in a percentage form, we times by 100. You notice I kept the entire figure there so we don't have any rounding off errors. And our interest rate is 10.4%. So in other words, what we're saying is that in order to keep up with inflation, the interest, the rate that will be applicable there is 10.4%. Okay, so in order for those salaries to double, these workers need to get a 10.4% salary increase in that 7-year period. Okay, all very practical and all easy to see in the real world. Just open up the newspapers and you'll see exactly what we're talking about. All right, let's move on to question 3. Now in this question, There is a little mention of exchange rates, but let's have a look, 'cause this one's got a little trick in it, and let's see if you guys hopefully picked it up and you've got the answer to this one at home. Okay, they say a laptop is imported from Germany when the exchange rate was 8.91 to the euro. Okay, the euro obviously being the currency in Germany. The retail price in South Africa at that time was 11,800 Rand. 1 year later, the Rand weakened. Now remember guys, when we're talking about a currency weakening, in this case we're talking about the Rand weakening, what it means is that it costs more rands to buy one of the other currencies. So in this case, euros. It costs more rands to buy 1 euro. And you can see that it says it weakened against the euro and the exchange rate was then 10.40 to the euro. They say calculate the expected increase in the selling price of the laptop based on the change in the exchange rate. So let's have a look at what happened here. Your exchange rate, it went from 8.91 to the euro to 10.40. So based on this change, based on this percentage increase, what can we expect to pay in a year's time for this laptop? So the first thing we've got to do is work out what the percentage change was. Okay, so we work out the percentage increase. All right. And hopefully all of you remember how to do percentage increases. So your final value minus your initial value, all divided by your initial value. Okay, and we times that by 100 to get our percentage. Okay, so let's do all of that on our calculator. So we've got 10.4 minus 8.91 all over 8.91, and that whole thing we multiply by 100, and that gives us 16.72%. So 16.72%, and that was your percentage increase. Again, you notice I haven't rounded off completely because I want to keep that value in the calculator so that we don't have any rounding off errors when we get to the end. So what we've said here is the Rand has weakened basically by 16.7%. So therefore, it should cost 16.7% more to buy this laptop. So how do we work out the new price of the laptop? Well, you simply take the old price, which is 11,800 Rand, and we find the percentage, 16.72% increase on 11,800 Rand. Okay, so I'm going to say 11,800 times 0.1672, so my percentage in decimal form. I want to see how much more in Rand terms am I paying for this laptop. Alright, so we take that, we times it by 11,800, and we see it's 1,973 Rand and 28 cents more. Therefore, I will now pay, a year later, you're going to pay 11,800 Rand plus this new amount of 1,000, or this increase in the amount, 1973.28. Again, I haven't rounded off. We've kept that answer on the calculator. So we're going to add to that 11,800 Rand. And we get 13,773 Rand and 29 cents. So it's 13,773 and 29 cents. Okay, so you're paying a whole close to 2,000 Rand just within a year, because of how these exchange rates have fluctuated, you're going to pay close to 2,000 Rand more just in a year. That's quite ridiculous. Hey, Looney. Shows you what happens with exchange rates. They change all the time. You pay almost 2,000 Rand to buy exactly the same thing a year later.
Okay, guys, I hope you're enjoying this revision session. If you are struggling and need help, please post on the page or send your questions to the Learn Extra Help Desk. The links are on our Facebook page. But now it's time to take a very quick break. Don't go away. We'll be right back. Welcome back, Mindsetters. Even though we are selecting highlights from previous shows, you can still follow me on Twitter @LearnExtra, or you can post or comment on our Facebook page. Now, let's do some more revision.
Okay, you were given marks in percentage form for a group of learners. And the first thing you would need to do is, when you look at that data, before you look at the questions and that, just look at it yourself and decide, well, what kind of data is this? Is it grouped? Is it ungrouped? Is it discrete? Is it continuous? You know, start asking yourself questions about the data so that when you start looking at the actual questions that they've asked you, you have an idea of where to go with this whole, where you can go with the answering the question. Okay, so we've got an entire set of data. First thing you should do, as I say, analyze that data. If you count the number of entries there, you'll see that there are 34 different marks. It is ungrouped because all the data is just given to you in this form. No grouping has been done with it at all. Is it, part A, discrete or continuous? Now remember, in order to answer this, you'll need to remember that discrete data can be counted, and continuous data has to be measured. So here we can clearly count the data, so therefore it will be, our answer here will be discrete data. All right? Part B, find the median, the lower and upper quartiles, and the interquartile range. Okay, before we can answer the question, part B, the first thing you guys will need to do is you take your 34 marks and you need to order them. You order them from smallest to biggest value, and then we're going to determine by looking, once we've got our ordered data set, we're going to then look at our values and determine our median, which remember is the centermost number, and then we're going to find our lower and upper quartiles and the interquartile range, which is the difference between the upper quartile and the lower quartile. Okay, so we've already arranged the data in ascending order, so from the lowest mark, which is 55, to your highest mark, which was 100. Okay, when we're looking for the median, remember it's the value that's in the centermost position. So we know that we're dealing with 34, which is an even number, 34 marks. So therefore, our median will be in the position between the 17th and 18th values. How did I get that? Well, 34 is an even number. If I take 34 and divide it by 2, I get 17. But it's not possible, if you look at your data and you order it, it's not possible to just have 75 as the middlemost numbers, because there'll be more numbers to the left or more numbers to the right than there are to the other side. So what you do is you then locate the position of the median as between the 17th and 18th value, all right, and you find what is the average of those two values. Okay, so we count, we've got 34. When you get to this point here, 75, that's your second 75, that's your 17th value. All right, so therefore the 75 next to it will be your 18th value. So what that implies is that our median is going to be between those two values. It's going to sit somewhere in between there. All right, so in order to find the median when it's between two values, you find the average. So it's 75 plus 75, so this is our median. 75 plus 75 divided by 2, which is 150 divided by 2, which gives me 75. All right, so therefore our median is 75, and it's located between the 17th and 18th data points. Okay. The next thing they wanted to do was to find the lower and upper quartiles. Now, once you've located your median, okay, we know it's in this position here. Your lower quartile, which is Q1, is actually the median. Okay, so Q1, to find Q1, it's the median of the lower half of your values. All right, so that means we're looking to the left of this, and we're finding the median of all of those values. All right, then in order to find Q3, you work out the median of the upper half of values. Okay, so then we go from the median point and we look to the right. Okay, we're going to find the median of the upper half and the lower half in order to get Q1 and then Q3. All right, so we know that there are 17 points up to this number here, 75. All right, so my median is then going to be in position. Let's have a look. Remember, when you're dealing with your median, it's actually going to then divide your lower half. We're looking for the median of the lower half of values. All right, so what it's going to do is it's going to take the lower half of values and it's going to divide those 17 points in 2. Okay, so let's have a look. Let's count with this and let's see where we get to. So there we've got 1, 2, 3, 4, 5, 6, 7. Okay, and that's 8 values up to there. And then if we go from there onwards, we've got 1. Let's take a different color. 1, 2, 3, 4, 5, 6, 7, 8 values. And 9 values up to 75. Now, if you need to divide your data set so that you get your centralmost number, okay, we're looking at 17. We divide that by 2. And what do we get there? 17 divided by 2, that's about 8.5. Let's just check. My mental maths is failing me. 8.5, there we go. So that means that your median is going to be in position 9. So let's count again. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And let's look at the number of values below the 65 and then the number of values above that 65. Okay. So here I've got 1, 2, 3, 4, 5, 6, 7, 8 values. And then there's my median of the lower half, right? So therefore there should be 8 values to the right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this median point, 65, divides your lower half into 2 equal pieces. So therefore Q1 is going to be equal to 65. All right, and then Q3, we do exactly the same thing. All right, again, there's going to be 17 sets of data to the right of our median, which was initially 75. So we know there's 17 sets, 17 pieces of data to the right of that. And again, you can do the same thing. 9 positions away from here is going to be your median of the upper half of data. So in other words, your Q3. Okay. Right, so let's have a count. So there's our 75. So that's 1, 2, 3, 4, 5, 6, 7, 8. And that one falls into position 9. Okay. And then we've got 1, 2, 3, 4, 5, 6, 7, 8. So this value of 85 divides your upper half of values into 2 equal pieces. Okay, so therefore what you've got here, if you have a look, you've got 1 there, our lower quartile. We worked out before our median, and now we've just worked out our Q1, our upper quartile. So therefore we've got the 3 values that divide this entire 34 pieces of data into 4 equal pieces. All right, so our Q3, our upper quartile, will be 85. Okay, so Q3 is 85. Now, what does this all mean? And I'm just going to erase this and leave the important pieces on so that we can investigate this a little bit further. So we've worked out median, we've worked out the lower quartile, we worked out the upper quartile. But what do these values actually tell us? Okay, so remember our lower quartile was 65, and we got our upper quartile as 85, and our median was here of 75. So what that tells us is that with the lower quartile of 65, it means that 25% of your values will be less than 65%. All right, so 25% of values lie between 55 and 65. The median, which was here at 75%, that tells us that exactly half of your values will be less than 75% and the other half will be greater than 75. I'm talking about the mark 75. All right, and then our upper quartile, which is Q3, tells us that 75% of values or 75% of marks is less than 85%, which implies that 25% must be greater than the mark of 85%. All right. Okay, guys, so it just takes a little bit of practice to get used to working out your lower and your upper quartiles and working out your medians. But remember, the key is when you've got just a list of numbers that are given to you and you've got discrete data, you have to first order that data before you can work out your median, and then before you can work out your lower quartile and your upper quartile, and our interquartile range, which is the difference between the upper and lower quartiles. Let's have a look at that one. So to work out our interquartile range, we say Q3 minus Q1, and remember this value tells you by how much the middle of the data differs. All right, so they differ generally by about 20%. Okay, so we say 85% minus 65, and that gives us an interquartile range of 20%. Now let's have a look at the last part, part C. They say find the 80th percentile and explain what it tells us about the marks. So your 80th percentile, remember, it's dividing your data into hundredths, and therefore you get 99 percentiles. If I want the position of the 80th percentile, I simply take the 80th percentile, so 80 divided by 100 gives me 0.8, times that by the number of values in your data set. So we say 0.8 times 34, and that gives us 27.2. So therefore, your 80th percentile will lie in approximately position 27. So we go to our data, all right, and we look at what number is in the 27th position. Now remember, up to here, that was 17, so let's count. That's 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, and we end up on this one here, 85%. Okay, what does this tell us? Because remember, this is the 80th percentile. So the 80th percentile is equal to 85%. Okay, what that tells you is that 80% of your marks were actually lower than 85%. So 80% of your marks were lower than 85%. Therefore, 20%, which is the remaining piece, is greater than 85. So put it in terms of people in your class, that means 80% of your class got less than 85%, and therefore the remaining 20% would have gotten a mark that's greater than 85%. Okay, so without further carrying on with discrete data, I want to quickly move on because I know we're going to run out of time. We've got so much to cover, Queen, so I'm not going to give you a chance to take a break. We're going to go straight into question 2 and deal with grouped data. Okay, so there we were looking at discrete, ungrouped data. Now we're looking at grouped data. We are given the mass in kilograms of 16 bodybuilders, and we are asked to calculate the estimated mean, estimated median, and the modal interval. Now the reason we're dealing with estimates here, because we've got grouped data, it's going to result in a slight loss of information. In order to work out your mean, you're not going to be able to work out the exact point at which your mean is, and we use the class midpoints in order to find the mean. This then implies that you can only get an estimated mean, and then we can also only get an estimated median because your data has been grouped into these class intervals. Okay, so we've got what's called a frequency table. We've got the mass, we've got the frequency. Frequency is how often that certain interval numbers occur in that interval. We've got our mass of 150 and x. Your mass is between 150 and 155. The frequency that happens with is 3. So in other words, 3 people have a mass between 150, let's say, kilos and 155 kilos. Okay, I'm going to dive straight into the first question, is to work out the estimated mean. Because we're dealing with grouped data, your mean is the sum of your frequency times the midpoint of your class interval divided by the total number of values. Okay, so it's the sum of the frequency of the interval times by the midpoint of that interval, and then that's all divided by the number of items we're dealing with. Now I've just included 2 more columns here because we need to put in our midpoint, okay? And then we need to work out a column for the sum of all of those values. So our midpoint, which we're going to call capital X, how do we work that out? You simply take the end points of your intervals and you divide by 2. So the first one is going to be 150 plus 155 divided by 2. Okay. Let's use our calculator. So it's 150 plus 155 divided by 2. That gives us 152,5. Can you do this all the way down the table? So first midpoint is 152.5. Okay, for the next one, I'm going to take 155 plus 60 and then divide that by 2. We'll just put our answers straight into our column there under midpoint. So it's 155 plus 160 divided by 2. And we get 157,5. Okay, let's just make that 2 a little bit more visible there. Okay, and then the third one is going to be 160 plus 165 divided by 2. That gives us 162,5. And then lastly, we've got 165 plus 170 divided by 2, 167,5. Okay, once you've got your midpoints for each of your intervals, you're now going to do a column where we add the sum of the, where we add up the product, of the frequency times the midpoint. Okay, so what we're doing here, so this column here, we're going to add everything together. Okay, but we'll do that at the end. For now, all we're doing is we're going to times the frequency by the midpoint. So I'm taking my midpoint, timesing it by the frequency, and putting the answer down there. Okay. So we've got first one 152.5 times 3. That gives us 457.5. Okay, your next one is going to be 157.5 times your frequency, which is 4. And that gives us 630. Okay, and then we've got 162.5 times 7, which gives us 1,137.5. And lastly, 167.5 times 2. So 335. All right, so we've times our frequency by our midpoints. Remember, why are we doing this? We need to work out the mean, which is the sum of the frequency times the midpoints divided by n, and n here is 16. So I'm now going to add all of those together, which will give me the sum of x times f. All right. Remember, guys, you can do all of this calculating on your calculator. You have statistic functions on your scientific calculator. If, however, you don't have a scientific calculator, although every one of you should do, then you can do it manually the way I'm doing it. But I want to show you the manual way so that you actually understand what you are doing and you're not just plugging random things into a calculator which just spews the answer out without any understanding. So we've got 25, the total 2560. Okay, so that's your total of the sum of your frequencies times your midpoint. And then in order to work out the mean, it's going to be that sum, 2560, divided by n, which is 16, the number of bodybuilders. So we take that, divide by 16, and we get an answer of 160. Okay, so therefore what that means is that the mean mass of the bodybuilders is 160 kilos. So on average, they weigh 160 kilos. All right, quickly, let's have a look at working out the estimated median. Now, your estimated median, again, because you're dealing with a class interval, you're going to use the midpoint of that interval for our median value. Okay, how do we work out what position the median is in? Well, we're dealing with 16 bodybuilders, so n is 16. So therefore, your median must be in position or between position. 16 is an even number, so between 8 and 9. Okay, so that's where your median value would lie. So we look at our frequency table and we have a look and see, well, where will the values of 8 and 9 lie? Where will the 8th and 9th data values lie? We can see in the first column we've got 3 and there we've got 4. So the cumulative frequency, if we add that, 3 and 4 is 7. Up to there we've only dealt with 7 bodybuilders. So therefore my 8th and 9th value will lie in this interval here. So therefore my estimated median is going to be the midpoint of the third interval. So your estimated median is going to be 162.5 kilos. And lastly, your modal interval, that's your interval with the highest frequency. Okay, and we can see that the highest frequency is in the third interval. So our modal interval will be x is less than equal to 165 but greater than 160.
Thanks for joining me and for chatting to me during the show. Please visit our website, learn.mindset.co.za, to get the notes and to watch the videos from earlier in the year. And remember, we are here to get you through the year, so stay connected. Goodbye.
To the power of 2, I use my compound interest formula to take this amount at time 4 and move it all the way to the end of the time period. when I've written it out like this, there's no need for me to round off or anything because I'm going to put this entire thing into the calculator and see what we get. Okay, so we've got 4,000. All right, Smart Ink. There we go. Smart Ink. Turn on, turn off. What do we do here? Hopefully that's gone. There we go. Okay, so we're going to write in exactly what we see. We've got 4,600 Rand. Simple interest, 1 plus 0.1 times 4. Close brackets and then close brackets again. That whole thing is going to be moved forward for 2 years at 12%, so it's 1.12. All I've done there is I've added the 1 and the 0.2, and that's going to be to the power of 2. Okay, so our entire calculation in one step, and we get an answer of 8,078.34. So 8,078.34 if we round it to the nearest cent.
Hello Mindsetters, welcome to today's Grade 10 Maths Show. Today we have a special revision lesson on finance and statistics. We have selected highlights from lessons shown earlier in the term to help you revise this term's work. So please post your comments and your questions on our Facebook page or on Twitter at LearnExtra so we can help you with your revision. You can also download the show notes for today's lesson from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
We are told that Dave invests 4,600 Rand for 4 years at 10% per annum, simple interest. Okay, very important point there. This is simple interest. So as I said, we don't really need a timeline, but let's use one. Again, the wrong line. There we go. All right, so he invested for 4 years. So starting off now, he's putting that money into a bank or wherever he's putting it. He's doing that investment now. So that's times 0. How much is he putting away? 600 Rand. And that is at a compound interest rate of 10% for a period of 4 years. Now, at this point, you can decide. You can either then use your calculator and work out what this value is. You can do that. So you can work out this value. If you're going to use your calculator at this point, guys, and you're going to work out what is the value of this 4,600 Rand, keep every single decimal point. Don't round off at all because the question is not yet over and you don't want to introduce rounding off errors. So at this point, if you're using your calculator, use your calculator memory and keep that entire figure in the memory which you're going to use for the rest of the question. I'm not going to use the calculator at that point. I want to show you guys the much more efficient way to do this. So this will give us the value or the value of the investment at point or at the 4th year, okay? But we then know that whatever's in there, so this entire amount, whatever's in there, is going to be reinvested at a compound interest rate of 12%. So if I want to move from time 4 to time 6, I simply need to take my accumulated amount and use my compound interest formula. So it's 1 plus 0.12. He's putting away 4,600 Rand. Okay? And this is invested for 4 years at 10%. So this is going to go all the way. So we've got year 1, year 2, all the way to year 4. Okay? And during that period, your interest rate or his interest rate is 10% per annum, simple interest. Now, guys, remember, if they're talking about simple interest, we need to just note here the formula we're going to be using is our simple interest formula, 1 plus I times N. Okay, so that's what we're using for the first 4 years, and you've been told that the interest rate in those 4 years is 10%. So we'll write the decimal form of that. So we do 10 divided by 100, and you get 0.1. Okay, so the interest rate at work for the first 4 years is 10% simple interest. Then he invests the accumulated amount. So whatever he has at this point in time, he then takes that and he invests it for another 2 years at 12% per annum, but now it's compound interest. So another 2 years. So we're going to carry on our timeline. We've got year 5 and then year 6. Okay, so whatever he's got at that point, he takes that and he invests it for 2 years at 12% per annum compound interest. Compound interest, that means for the final 2 years, what are we going to be using? The compound interest formula. Okay, 1 plus I to the power of N. Your interest rate at work in those last 2 years, in decimal form, we're going to take 12 divided by 100, and you get 0.12. So your interest rate here is 0.12. Once you've summarized everything into this timeline, guys, it's actually very easy to then decipher or decide what it is that you need to do from your timeline, okay? You can see that he put that amount in, 4,600 Rand. That is then worked on by simple interest for a 4-year period. At that point in time, time 4, whatever accumulated amount is in that account is then invested for a further 2 years, and that is then at a compound interest of 12%. So let's write all of this down into a solution. All right, so I'm going to say at time 6, so at the end of the period, the final amount is going to be equal to the initial amount, which is 4,000.